Inkjet printer technology is truly the magic of CMY colors. The engineering behind the droplets and how the color algorithm creates the final image is pretty clever. We all know that display technology consists of minute red, green, and blue subpixels. As an experiment, one of our engineers at Lessix filled her inkjet printer with the same RGB colors. Let's take a look at her printer output. The result was terrible. The printer couldn't reproduce the image of the flower with the correct colors. To understand the reasons behind this intriguing result, let's explore the inner working of the inkjet printer and color science. First, consider the most fundamental inkjet technology, the black and white printer. You can print any image with a collection of many dots. These dots are produced by drops of ink being released from many nozzles. The ink is not dropped continuously, but in a discrete and controlled way, as shown. The small circumference of the nozzle and back pressure inside it won't allow the ink to leak out, allowing for a precise image. To release the ink, we must use these small heating resistors. These resistors are so responsive that when the electricity runs through them, they gain around 100 degrees Celsius per microsecond. To release a drop of ink, simply supply power to the respective resistor. It will then heat up and vaporize the ink, thus forming a bubble. This bubble acts as a piston to push the ink out of the nozzle. However, when the primary drop is falling, the ink gets elongated due to viscosity. As a result, it forms one more drop, which falls near the primary drop. After some time, both drops combine. While focusing on the drop, you may have missed one important process. Let's replay the animation again. This time, direct your focus on the top region. Here, after some time, the heater is turned off, causing the vapor around the coil to condense and the bubble to collapse. The back pressure of the ink sucks outside air into the nozzle. Immediately afterwards, the surface tension of the meniscus will play an important role by working against the back pressure, forcing the fresh ink to fill the nozzle and remove the air from it. Now that we've established the fundamentals, let's see how to build a practical printer. An ink tank is connected to the print head via a connection pipe, which is free to move along this horizontal rod. The printer also uses a belt and pulley mechanism powered by a stepper motor. Next, connect the print head with a belt using a movable arm. You can see how the head moves left and right along with the movement of the belt. Let's start the printing now. As we saw earlier, the head can print a series of black dots by properly controlling the heating resistors. The printing example you see here is highly exaggerated for ease of understanding. The actual print head size is a fifth of this head. Notice how the head produces 9 lines during a pass, but the actual head produces more than 1,000 lines. One pass has been completed. Now, we have to continue the printing process in the remaining area of the paper. For this, a roller stepper motor and 2 supportive roller arrangements come into play. This arrangement can move the paper downward. Now, just repeat the process we saw earlier until the print finishes. The print head movement shown here is not so smart. It doesn't do any printing during movement from left to right. Also, the print head takes many unnecessary steps. Modern printers are equipped with clever algorithms which make this process faster. The optimal printing path of a print head and precise paper roller movement is calculated even before the printing process starts. You can see how fast this printing is now when the print head follows this predefined path. Obviously, this path will change drastically based on the image you want to print. The printhead and paper are able to follow such a precise path because they are controlled by a stepper motor and a feedback circuit. Till now, we have constructed a basic black and white printer. But how can we use the knowledge what we've learned so far to develop a color inkjet printer? The most obvious and intuitive answer seems to be to use red, green, and blue ink since these are the fundamental colors of display technology. However, this just won't work. To understand why, let's explore the fundamentals. Consider two colored flashlights. One is red and the other is green. When we flash both torches at the same point, the resulting light is yellow. Now, let's try the same experiment using ink colors. When we mix these two colors, we instead get a muddy yellow color. Why do these two experiments produce totally different output colors even though the input colors are the same? The first case in which we mixed lights was an example of the additive color mixing method, while the second case with the ink is a subtractive mixing method. The additive mixing method is so simple. The combined light portion directly reaches your eye and you see that color. However, the subtractive method is a little tricky. The lights reflected from the ink are important here. To better understand how the subtractive method works, we need to examine the ink at a molecular level. We know we see a red color because the red molecule absorbs everything except red. In short, what we see in an ink color is the remaining color after the subtraction. The same is the case with the green color. However, when we mix both colors, the physics becomes more interesting. Since one layer of molecules cannot completely fill a surface, we should consider at least two layers for this study. Here, we are assuming that the different color molecules are uniformly mixed as shown. Let's start with the bottom green molecule. The green molecule will obviously reflect green light. However, this green light has to pass through the upper molecular layer. You can see this top green molecule will just allow this green light. However, the neighboring red will completely absorb this green light. In short, that area will produce a black color. Now let's consider the light coming from the bottom red molecules. When you do the analysis the same way, this is the final output. The black is present in a good portion between the red and green lights, which affects the final output color. This muddy yellow color is what our eye sees due to the presence of black. A good example of the understanding of the effect of black color in the final output is this gray hair example. We see the overall color of the hair as gray, but in fact, it is a blend of white and black hairs. This is why the subtractive method is totally different from the additive method, and why we got horrible printout when we used RGB colors in the printheads. So far, we've learned that we can't use primary colors to reproduce colors, and the subtractive method is the villain. The color we see in an ink print is in fact the inverted portion after the absorption. The solution to this issue is simple. Just invert the fundamental colors. The inversion colors of red, green, and blue are cyan, magenta, and yellow, respectively. Thus, these are the colors we must use in the printer. Here's an example. We want to produce a green color using these CYM colors. First, release a drop of cyan ink from the nozzle. Before this drop dries up, release a yellow droplet at the same location. Mixing these two colors will produce a perfect green color. After some time, the drop gets absorbed in the paper and we get a green dot. Similarly, as shown in the animation, we can produce most of the colors with perfection using CY and M droplets. We saw how to produce a perfect green color in an inkjet printer. But can we produce a lighter shade of green like these? To achieve this, clever engineers have tricked our eyes. They just printed the normal green color with different spacing. Increased spacing tricks the brain into seeing a lighter shade of the color. Now the next task. How to produce the darker shade. Darker shades cannot be achieved just by using C, M, and Y. The printer has to use black ink as well. The black ink is referred to as K, where K stands for a key. Now, let's understand the mechanism behind dark shades of green color printing. The obvious answer will be just mixing a black ink droplet with green color. Logically, it's correct, but there's an issue with this method. You won't be able to increase the darkness of the green color by a small degree, since the droplet size of the black and green are the same. To achieve different shades of the colors accurately, here again the engineers tricked our eyes. Just drop a black ink droplet in between green droplets according to the shade of green color. It will trick the brain into seeing a darker shade of the color. The printer quality of modern printers is quite high due to the very small size of the ink drops. The smaller the drop, the higher quality of the print. For decent quality, we required more than 300 dots per inch square of paper. However, to achieve even more incredible results, the modern printer has 2100 to 4200 nozzles per printhead. Thank you for watching this video. We hope it gave you a clear understanding of what goes on inside your printer. See you next time.